Is consciousness a bridge to other realities? What if your consciousness isn't entirely confined to this reality? What if it's not just a neat trick of your brain, locked inside your skull? That's the old, comfortable model. But on the wild frontiers of physics, some researchers are asking a radical question. Could our consciousness be a key to understanding a universe far grander and stranger than we can possibly imagine? A universe that might have up to 11 dimensions. Now let's be clear. That is an incredibly bold question. We don't have a lab experiment that proves this. But the mathematical language of our most advanced physics, mixed with a few controversial but fascinating theories, points in a direction so mind-bending it could change everything we think we know about the cosmos and our place in it. Hook. Have you ever had a jolt of intuition that turned out to be spot on? A dream so realistic it stuck with you for days? Or a sense of déjà vu so powerful it literally stopped you in your tracks? What if those weren't just quirks of your mind but something more? Could they be fleeting glimpses into these other possible realities? This is where science gets speculative, sitting right on the edge of what we can claim to know. And today, we're going to follow that thread and see just how strange things might get. Section 1. The world we know and the prison of our senses. Let's start on familiar ground. We experience the world in 3 spatial dimensions: length, width, and height. You can move forwards and backwards, left and right, up and down. Easy enough. Add time as the 4th dimension, and you've got the basic fabric of space-time, the stage where our lives unfold. This 4-dimensional world feels complete. But is it? The reality is, our perception is fundamentally limited by our own biology. We evolved to spot dangers on the plains and find food, not to contemplate the architecture of the cosmos. Our senses are just tiny windows looking out onto a reality that is likely unfathomably vast. To get a handle on this, physicists love a thought experiment called Flatland. Imagine a universe that's totally 2-dimensional, like a drawing on a piece of paper. The beings there, the Flatlanders, have length and width, but zero concept of height. For them, up is a meaningless idea. Now imagine you, a 3D being, stick your hand through their 2D world. You wouldn't just appear. To the Flatlanders, you'd first show up as a few separate points, your fingertips. As you pushed your hand through their plane, those points would grow and merge into bizarre, shifting shapes, finally becoming the cross-section of your palm. From their point of view, it would seem like magic, a being materializing from nowhere, changing shape, and then vanishing. They could never see all of you at once because they simply lack the dimension of height. So, here's the question. What if we're the Flatlanders? What if there are 4, 5, or even 11 dimensions all around us, but we're just as blind to them as the Flatlanders are to our 3rd dimension? There could be entire structures, worlds, and phenomena existing in the same space we do, completely invisible simply because we don't have the biological gear to see them. This isn't just a fun thought experiment. It's the starting point for some of the most advanced and puzzling physics of our time. Section 2. The physics of hidden worlds. For decades, physics has had a huge nagging problem. We have 2 theories that are fantastically successful. General relativity, Einstein's theory, perfectly describes the universe of the very large, planets, stars, galaxies. And quantum mechanics perfectly describes the universe of the very small, atoms and the particles inside them. Both work. But when you try to get them to work together, the math falls apart. They're incompatible. It's one of the biggest unsolved mysteries in all of science. This is where string theory makes its entrance. It's a top contender for a theory of everything, a single framework that could finally unite gravity and quantum mechanics. String theory's big idea is that the fundamental building blocks of reality aren't tiny dots, but tiny, one-dimensional vibrating strings. Everything, an electron, a photon, you, is just the same kind of string humming at a different frequency, like notes on a cosmic guitar. It's a beautiful idea, but for the math to hold together, it needs something staggering: more dimensions. Depending on the version of the theory, it requires the universe to have 10 or 11 dimensions in total. So, Where are they? If they're real, why can't we see them? The leading idea is that these extra dimensions are compactified, curled up on a scale so impossibly tiny, far smaller than an atom, that we never notice them. Think of a garden hose. From far away, it looks like a simple 1D line. But for an ant walking on its surface, there's clearly a second dimension, the circle around its circumference. The extra dimensions of string theory are thought to be like that, just curled up on a scale we can't detect, even with our most powerful tools, like the Large Hadron Collider. For a long time, these dimensions were treated as a mathematical quirk, necessary for the theory, but not something we could ever touch. But what if that's not the whole story? What if some part of us isn't limited to the 3 dimensions we can see and touch? Section 3. The Consciousness Bridge, a wild hypothesis. This is where we take a leap, moving from theoretical physics into the realm of profound speculation. And it all centers on the biggest mystery of all, consciousness. What is it? We know it's tied to the brain, but scientists and philosophers have struggled with the hard problem. Why do we have a subjective inner experience? Why does it feel like something to be you? A controversial but intriguing idea comes from physicist Michael Pravica, who suggests we might be looking in the wrong place. What if consciousness isn't just generated by the brain's hardware? What if, he speculates, consciousness is our bridge to these higher dimensions? Pravica argues that just as a 3D being would seem godlike to a 2D flatlander, maybe figures of great insight throughout history were just people more in tune with these higher dimensions. He proposes that eureka moments, sudden creative breakthroughs, or even vivid dreams could be our consciousness briefly syncing up with these hidden realities, downloading information not just from our own minds, but from a higher dimensional space. The fact that we can even think about higher dimensions and describe them with math is, as Pravica says, something that seems to transcend biology. Our brains are 3D, our bodies are 3D, but our minds, our awareness, maybe they aren't so limited. It is absolutely crucial to state that this idea is met with major skepticism from mainstream science. As physicist Stephen Haller points out, just because we can describe higher dimensions with math doesn't prove they physically exist or that we can access them. These ideas currently border on science fiction. There is no direct, empirical evidence, not yet, but it's a fascinating potential answer to some of our deepest questions. And if you're enjoying this journey to the edge of what we know, take a second to hit that subscribe button. We tackle the biggest questions in the universe every week, and you won't want to miss what's next. Section 4. What about parallel universes? The idea of other realities doesn't stop with extra dimensions. Another mind melter comes directly from quantum mechanics, the many worlds interpretation, or MWI. In the weird world of quantum physics, before you measure a particle, it exists in a cloud of all its possible states at once, a superposition. When you look, it snaps into just one definite state. The big mystery is, what happens to all the other possibilities? The many worlds interpretation gives a wild answer. Every single possibility happens. Each time a quantum event has more than one possible outcome, the universe itself is thought to split into multiple branches. In each branch, one outcome becomes reality. This means that, in theory, there's another version of you that chose not to watch this. Another you that took that job you passed on. An infinite number of parallel universes, branching off with every single quantum event. For a long time, these parallel worlds were thought to be completely separate, forever unable to interact. But again, some can't resist asking, what about consciousness? While the mainstream many worlds theory does not propose we can sense these other worlds, the speculation is irresistible. Could a vivid dream of a different life be a faint echo from an alternate you? Could déjà vu be a moment your reality briefly aligns with a nearly identical parallel one? There's absolutely no scientific evidence for this, but it's a compelling idea that reframes our most mysterious mental states. Section 5. The quantum brain? The final piece of this puzzle brings us back inside the brain, but with a quantum twist. For decades, the brain has been seen as a fantastically complex biological computer. But a minority of scientists, like physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff, argue that a classical computer can't explain the richness of conscious experience. They developed a highly controversial theory called orchestrated objective reduction, or OR. It suggests that consciousness isn't classical at all, but arises from quantum computations happening deep inside our neurons, in tiny structures called microtubules. This model suggests these quantum processes could allow the brain to function in ways a simple computer never could. If consciousness is a quantum phenomenon, it opens up a whole new world of possibilities. Quantum mechanics includes entanglement, where particles are linked, affecting each other instantly over vast distances. If our brains operate on quantum principles, it adds a sliver of theoretical plausibility to the idea that our consciousness might not be strictly local. As of 2025, it's critical to understand that these quantum brain models are unproven and are not accepted as consensus science. They face major criticism, including how such delicate quantum states could survive in the warm, wet environment of the brain. Still, it remains an active and exciting frontier of research. Conclusion: a new kind of reality. So, has science proven that consciousness can access other realities? The honest answer is a firm no. There is no definitive, repeatable, lab-tested proof. What we have is a collection of mind-bending but plausible theories from physics that tell us extra dimensions and parallel universes could exist. We have speculative but brilliant hypotheses that try to connect those physical theories to the deep mystery of consciousness. And we have tantalizing, though unproven, clues from the fringe of neuroscience. What we're witnessing is a potential shift in perspective. We're moving away from the old idea of a simple clockwork universe we are just watching. The new picture that's slowly emerging, from the strange math of string theory, from the philosophical questions of many worlds, from the controversy of quantum consciousness, is one of a participatory universe. A universe where consciousness might not just be a passenger, but a player in a game far bigger and stranger than we ever knew. The big idea isn't that you can just decide to hop over to another dimension. It's that reality itself might be infinitely more layered and complex than it appears, and the tool we have to even ask these questions is the very thing we're trying to understand: our own consciousness. The next time you have a flash of insight, a moment of deep intuition, or a dream that feels more real than life, maybe you'll pause and wonder, were you just thinking? Or were you for a fleeting moment perceiving something more?